Again, the very first method we're going to talk about is the very first step of factoring. And that is taking out a what? Greatest common factor. So your first step, whenever you're factoring, is always to take out the greatest common factor, also known as a, what's the abbreviation for it? GCF. Again, if possible, you always take out a GCF first. Get that in your brains. When you're factoring, always ask yourself, before you do anything, can I take out a GCF? And then you look to try to factor the rest. Okay? Today, because we're learning or reviewing GCF, we're not going to factor the leftovers, but always ask yourself that whenever you're factoring. When taking out a GCF, you find the largest number that can divide into the given numbers. Has to be the largest. And sometimes there's more than one that can go into both or all three, but it has to be the largest. Okay? When you're trying to find the GCF between variables, you're always going to take out the one with the smallest exponent. So numbers, it's the largest, right? The largest one that can divide into the given ones. And for variables, it's always the one with the smallest exponent. Okay, a little backwards. Questions over there? So, take a look at this first one. Look at your numbers. What are the two numbers they gave us? 5 and 10. So what's the biggest number that can divide into both 5 and 10? 5. Okay. So what I like to do a lot of the times is see, can the little number divide into the big number? If it can, that's going to be your GCF. Okay. Then look at your variables. Do both terms have a variable? Do both of them have an x? No. So can we take out an x? No. They both have to have one. If they both don't have one, you're only taking out a number. Okay. So our GCF is 5. Then you have to put a parenthesis and write your leftovers. To write your leftovers, you just divide out your GCF. 5 divided by 5 is what? We didn't take an x out, so that's still there. 10 divided by 5 is 2. Done. And make sure the signs in between the terms stay the same. Those don't change. So there's a plus sign there. You're just going to drop down the plus sign. Questions over there?
All right, number 2, kind of similar to it as well, but a little bit different. Now, I do myself a little differently. Some of you guys can see this abstractly and say, all right, I know 5 goes and divide it out. Some of you guys have to visually see what's going on. So I'll show you a visual way. Doing the same exact thing, it's written out a little bit longer, but it helps people organize their thoughts. So just like Ms. Baker said before, typically we look at the smallest number, because a lot of times the smallest number is the GCF. In this case, what is the smallest number out of these two terms? 6. Does 6 evenly go into 15? No, it does not. So we know the number has to be smaller. So what is the largest, well, the number that's smaller than 6, but goes into both 6 and 15? What's a factor that goes into both? 3 is the largest factor, right? So I'm going to put that 3 out in front just like I did before. Do they both share a variable? No, that 15 does not have an x, so we know our GCF is just that. So here's what I do a little bit differently. There's 2 terms. I'm just going to divide each term by the GCF. And then the leftovers will drop down inside of the parentheses. Well, what's 6 divided by 3? 2 will fall down right in that area. Does anything happen with that x? Drops down. It's a plus. Keep it a plus. 15 divided by 3, 5. There's your answer. Not much different than that. It's just sometimes it helps, especially later on when we get more terms of the GCF, more pieces of the GCF, it will change. Question on that? Again, you guys are like, yeah, I remember this stuff. I'm going to do really well. 3 and 4. Yes, we are. You're going to say there's a test over this easy stuff? Yeah, there is. So I should do really well on this test? Yeah, you should. Wow.
So look at number 3. Can 6 smaller number divide into 14? No, we have to start thinking of other factors. So what is the largest number that can go into both? Do both of these terms have an x? Oh, can we take one out? Oh, write our leftovers. When we write our leftovers, we just divide out the number. 6 divided by 2 is 3 minus, make sure that sign drops down. 14 divided by 2 is 7. Again, we didn't take out an x, so we just did it. If we take a look at 4, look at the numbers. We have 3 and 6. What's our GCF between 3 and 6? 3. Yeah, the little number can divide into the big number, so that's going to be our GCF. Do they both have a variable? Yeah. We have an x squared and we have an x. And we said when this happens, we take out the one with the smallest exponent. So ignore the coefficients. We're just taking a look at the variables and their exponents. So in the first term, we have an x squared. And the second one, we have an x to the first. Which one's smaller? X to the first. So that's going to be our GCF. Then write your leftovers. Again, just divide out the number. 3 divided by 3 is what? Here we started out with 2 x's, and we took 1 x out. So then how many x's would we have left? 1. Just 1 x. Start with 2, you take 1 away. 1 is left. 6 divided by 3 is what? We started out with an x, but we took that x out. So how many x's would we have left? We started out with 1 and we took the 1 away. How many would we have left? 9. So do we need to write an x there? No. No. We have to be careful of that.
All right. You guys are saying, man, I still remember this stuff. I'm so good. All right, well, we're going to keep throwing curveballs at you. What about this one now? 5. Well, if you look, we got some different things going on. The larger numbers in front, smaller number being 5 in the back. We've got an x squared. Well, let's go. Well, let's start with the same process. Let's look at the constant, the number in front. What 2 numbers am I dealing with here in this case? What? What 2 numbers are in this term, or this problem? 20 and 5. What is the greatest number? Well, first off, does 5 go into 20? Yeah. So there's our GCF as far as the constants go. So I'm going to say 5 does. It does. Do they both share a variable? Okay. What is the smallest variable of these 2? Well, we have an x and an x squared. Which one's smaller, x or x squared? X. So the most I can take out of both is an x. Down the road, you'll see some problems have like x to the 7th and x to the 5th. Well, between x to the 7th and x to the 5th, which one's smaller? X to the 5th. That's the most you can take out of that. So we do have our GCF of 5x. We know the leftover is going to fall down, so I'm going to divide each term by 5x. Leftovers fall right down in there. 20 divided by 5. 4. X over x. What happens when you have x over x like this? Cancel out. If they subtract, that's really what's happening. That's why we cancel things out. What do we do? Because they're really subtracting one another. 5 divided by 5. 1. X squared over x. I had 2 x's up top, 1 down low, so you're just left with 1. I don't know if the trick's going to work here in that case, but I like where you're going with that one. Numero 6. Smallest number is 10. Does 10 evenly go to 25? So the number has to be less than 25. Okay, that sounds cool. What number? 5. We know it. It's ends with a 0, 5. 5's our only other choice. So we got 5 going on here. Cool. Do they both share a variable? Do they both share a variable? No? Moving on. Oh, it is yes. What is it? They're both x's. What is the smallest of those x's? X. First, just 1 x. There it is. So I'm going to divide each term by 5x. Wait a second. Are they always going to be 5x in GCF? Because that one is. No. Why did you even ask that question? Just happened to work out that way.
You asked that question.
You're the one. I see my voice change, so the recording knows that a student asked that. Here's my voice. Here's you guys talk. See, there's a difference in voice.
Why is ours deeper?
You guys you went through, you matured much faster than I did. So let's go through with this. 10 divided by 5 is? I heard someone say 2, or they sneezed, one of the two. 2. All right. X squared over x is? Oh gosh. X squared over x. Just 1x, thank you. Plus sign drops down. 25 divided by 5. X over x is? They go. They cancel out. So, what's your answer? Here's a scenario. Some people ask this. Again, this is really... They say, all right, well, if I had to solve this, what would be my next step? When I have a number outside of parentheses, what do you guys typically do? Distribute a D. Now, does it help me to distribute? If I plug this back in, what's ultimately going to happen? Yeah, it's going to be the exact same thing. This is the factored form of that. They're equivalent, so the numbers will be the same, whatever represents x. But the reason why that's helpful, if you guys had a multiple choice test or something along the lines, they might say it's a question of which of these factored forms is equivalent to this answer. You would have to FOIL it back in, or factor it back in together, distribute it back, and see if you get the same answer. So distributing it back in won't really help you here in this case. So some people like to say do this and FOIL it, you'll get the same answer. So don't have to worry about it. Ready, set, 7, 8.
Okay. If you look at 7, you might notice now there's 3 terms rather than just 2. And the steps are still exactly the same. Okay? Except they're dealing with 2 numbers, you're just looking at 3. So we look at 7, what's the largest number that can go to 2, 8, and 10? Do all 3 terms have a variable? No. So can we take one out? No. So only GCF is a 2. Okay. So when you write your leftovers, just divide it out. 2 divided by 2 is 1. We didn't take any x's out, so that stays the same. 8 divided by 2 is 4. Again, didn't take any x's out, so that stays the same. 10 divided by 2 is 5. Done. If we look at 8, again, look at all 3 numbers. What's the largest number that can go into 8, 12, and 20? 4. Very good. It's really tempting to say what? 2, because 2 can also go into all 3, but there's a bigger one that can go into all 3, and that is 4. So you have to be careful with ones like these. Sometimes there's more than one. It has to be the biggest. Then if we look and see, do all 3 have a variable? Yeah, all 3 of them have an x. Which one's smaller, x cubed, x squared, or x? X. That's the one with the smallest exponent. So when you write your leftovers, 8 divided by 4 is what? 2. We started out with 3 x's and we took one out. How many are left? 2. So the x squared. Make sure that sign stays the same. 12 divided by 4. We started out with 2 x's and we took one out. How many are left? And then 20 divided by 4 is 5. We started out with an x, but we took that x out. So do we have any x's left? Questions over there?
All right, 9. Still got that trinomial going on. 3 terms. So we got to look at all 3 to figure out what it is. Well, what term or what number goes into all 3 terms? 5 does. So 5 goes into 10, goes into 20, goes in that. So that's what it's going to be. So we're going to put 5. Do they all share a variable? No. So it's just going to be 5. So we'll divide this by 5, put my parentheses, divide that by 5, divide that by 5, divide that by 5. All right? Then we're going to divide it out. What it goes to, right? do there? Maybe so funny, huh? Alright, 5 divided by 5 divided by 5. So, when we do this, 10 divided by 5 is, what is it? 2. Meaning there, funny guy. Let the record know he's been deleting my stuff. So it is a 5. It's going through. It gives a 2. Does anything happen with that x squared? It drops down, you're right. It's a sign. 20 negative is the sign, so it drops down. 20 divided by 5 is 4. Nothing happens with an x, stays x. 5 divided by 5, 1. What is that, Derek? Not gonna work.
No, I didn't. I don't know what happened. It was just like slowly.
Because you were messing with it. All right, 10. That was disappearing ink because I'm a magician. So number 10 up here. Still that trinomial. Make sure we're dial in. I know the last one you guys get excited for factoring. Still 3 terms. What is the smallest number of these terms? Up here, it's a 6, right? Does 6 go into all these? 6 goes into itself. Does 6 even go to 15? 20? Okay. So, we got to find a factor that goes into it. So, what's the smallest factor of 6? Well, not small. Next smallest one would be 3. All right. 3 goes into 6. 3 goes. Does 3 go into 20? Okay, 2 then. 2's got to work. 2 go into 6. 2 doesn't go into 15. So, it's got to be 1. 1 is my number. Okay. A lot of times we don't like when you take out 1, but we'll see here. Do they share anything else? They share an x. So I can take out 1x. This happens sometimes where you don't have a constant, you don't have a number in front. You just have the variable. If you want to put a 1 in front, yeah, that's fine. But that's what it's going to be. It's just going to be an x. So I'm going to divide each of these by x. Well, is anything happening with that 6? Falls right through. So it'll sit in front like you did normally did. X cubed over x. I have 3 up top, 1 down low. How many are going to be left? 2. We just subtract it out. So x squared, as we call it in the biz. 15, nothing happens to that guy. Drops down. X squared over x. 5 sides plus. Nothing goes on with the 20. What happens with those x's? They go. And there you go. That's the factor form of this one. So sometimes the variables themselves are the factors. So be aware of that, for favor. Questions with this? You guys remember you have blast from the past? Some of you guys probably have nightmares about this stuff. But the GCF nightmare.